In this video, we are going to learn about units and measurements. So we'll be looking at fundamental and derived quantities in physics. So let's begin with fundamental quantities. So what are fundamental quantities? They are simply those quantities in physics in which other quantities depend on. Alright, so we have basically about 7 of them. So let's begin with mass. Alright, so mass is a fundamental quantity and the unit of mass is kilogram. That is measured in kilogram. Short form is kg. We also have our length. The unit of length is meter. Short form is m. We also have our time. The unit of time is seconds. Short form is x. We also have our temperature. The unit of temperature is Kelvin. Short form is K. Alright, we also have our electric current. The unit of electric current is ampere. Short form is A. Alright, we also have our amount of substance. Amount of substance. The unit of amount of substance is mole. Short form is mol. Okay, we also have our luminous intensity. So the unit of luminous intensity is candela. Short form is CT. Alright, so these are the 7 fundamental quantities we have in physics. Now note that all these quantities here are scalar quantities. As we all know, in physics, scalar quantities are those quantities in physics that have magnitude but no direction. So all the fundamental quantities here are scalar quantities. Alright, so having known this, let's wipe this now. Look at derived quantities. Okay, so what are derived quantities? Derived quantities in physics are those quantities that are gotten by simple combination of 2 or more fundamental quantities. So when you add 2 or more fundamental quantities, it will yield or give you a derived quantity. So let's look at a couple of them. We have area. Area is one of them. So as you know, to calculate area is calculated using length times breadth. Okay, and its unit is meter square. We also have volume. Volume is calculated using length times breadth times height, and its unit is meter cube. We also have density. Density is calculated using mass over volume. So the unit of density is kilogram per meter cube. Right, so we also have our speed. So speed is calculated using distance over time. So this is n, distance by time, and the unit of speed is meter per second. Alright, so we also have our velocity. So velocity is calculated using displacement over time. Displacement over time, and it has the same unit with speed, meter per second. Now the difference between speed and velocity is that speed is a scalar quantity, whereas velocity is a vector quantity. Speed has magnitude but no direction, but velocity has both magnitude and what? Direction. Right, so we also have acceleration. Acceleration, which is calculated using velocity over time. Alright, so the unit of acceleration is meter per seconds square. Okay, we also have our force. So force is calculated using mass times acceleration, and the unit of force is Newton. So the short form is N. Okay, we also have our weight. Now, weight is calculated using mass times acceleration into gravity g, and its unit is also measured in Newton. And short form. Alright. The difference between weight and mass is that mass is a scalar quantity, whereas weight is a vector quantity. Alright, so that's just the major difference between weight and mass. Alright, so let's look at another example of a derived quantity. Okay, we also have our momentum, which is calculated using mass times velocity. Alright, so the unit of momentum is Newton second. The unit of momentum can also be kilogram meter per second. So any of these can serve as the units of momentum. Alright, we also have our pressure. Pressure is calculated using force over area, and the unit of pressure is Pascal. Alright, so you can also have other units, but the common unit is Pascal. Okay, so let's wipe this and look at a few more examples. Okay, so we also have work, which is calculated using, so work is calculated using force times distance, and its unit is joules. Short form is. We also have energy. Alright, energy, there are various ways you can calculate energy. We have kinetic energy, we have potential energy. Alright, MGH, you can calculate energy using MGH. You can also calculate using half mv square. Alright, depending on the type of energy you are dealing with, and its unit is also joules. Energy is also measured in joules. Okay, now it depends. You can also calculate energy using force times distance, depending on the situation you have. Alright, so energy is a derived quantity. The difference between energy and work is that energy is a scalar quantity, whereas work is a vector quantity. Energy has magnitude but no direction. Work has both magnitude and direction. Okay, we also have our power. So power is calculated using work over time, and is measured in watts. Alright, so we also have our impulse. So impulse is calculated using force times time. Okay, so the unit of impulse is Newton second. We can also measure impulse in kilogram meter per second. So anyone will work. Okay, so these are the basic derived quantities we have in physics. We have others, but these are the basic ones. Alright, so with this we have come to the end of the class. Now note that you should get yourself familiarized with these various quantities and their units, because they are very important. It will help you in the discipline of physics in the long run. Get yourself used to them if you want to be a good physics student. Alright, so that's for this class. Thanks for watching. Hope you learned something interesting. In this video, we are going to learn how to find dimension of physical quantities in physics. Alright, so ensure you stay to the end of this video. I'm going to simplify everything. Okay, so it's important to note that the essence of dimension of physical quantities is to show how a derived quantity can relate to the fundamental quantities of mass, length, and time. Alright, so having known this, let's look at examples. What if we are asked to find the dimension of velocity? So how do you go about it? As we all know, velocity is calculated using displacement over time. Alright, now when you talk about displacement, you're talking about your length of something, right? That means it will be measured using length, whereas the time will remain the same, since you're looking at how this derived quantity will relate to this parameter we have here. So this will be the dimension of velocity. It's either you leave it this way or you leave it like this, length per time. It's mostly like this. Alright, so this is the dimension of velocity. Now let's look at another example. What if we are asked to find the dimension of acceleration? Okay, acceleration is calculated using velocity over time. Now, and you know, velocity is over time, and we know that when we talk about distance, we're talking about length, right? Length This time around, we now have 2 time in this expression. That means length over t square, and this will be the dimension of acceleration. Let's leave it like this. This is how it is normally expressed. We not normally leave it in this format. They leave it in this format, length per time square. So this is the dimension of acceleration. Alright, so what if we ask to find the dimension of force? What would be the dimension? So force is calculated using mass times acceleration. Alright, since mass is relating to this, the mass will remain the same. So we have mass times acceleration. Dimension of acceleration here, we have it to be length per time square. Alright, so this dimension of acceleration. So when you add everything together, we're going to have dimension of force to be mass times length times per time square. Alright, this is 2. This is dimension of force. Alright, so let's write this and solve another example. Or if you're asked to find the dimension of momentum. Alright, so momentum is calculated using mass times velocity. That means, remember, we are looking at how these derived quantity relate to mass, length, and time. That means mass will not change because mass is relating to this. So we have it to be mass times the dimension of velocity. We had it to be, this is velocity equals displacement over time, which will be length over time. The length per time. So it will be mass times length per time. So when you bring everything together, it will be mass times length per time. And this is the dimension of what? Momentum. Alright, so what if we are asked to find the dimension of density? What is it going to be? Density is calculated using mass over volume. So mass will remain the same. Volume is the length cube. Volume is length times breadth times height. So everything here is talking about length. That's why we have 3 lengths there. That's why we have length cube. So when you express it this way, it's going to be mass per length cube. So this will be the dimension of density. Let's write this and solve another example. Okay, what if you ask to find dimension of pressure? Alright, pressure is calculated using force over area. Alright, and force is mass times acceleration. Force is mass times acceleration, right, over area. Now remember, we got the dimension of force to be mass times length times per time square. Let me show you. Force equals to mass. Mass will not change. Since mass is related to m, we have mlt. So mass is related to m here out of the l and t. So mass is related to the m here. Alright, then mass will not change, and acceleration is velocity over time, and velocity we're talking about displacement over time. So we have 2 time here, right? And this v and d are talking about length. So we have length per time square. That's how we got this. Alright, so don't be confused. So the dimension of force is mass times length times per time square. Alright, over area is talking about length times breadth. Right, that's how you calculate area. Length times breadth. Okay, that means we have 2 lengths here. So dimension is length square. That will be the dimension. Alright, so we have mass times length per time square over length square. Alright, so when you do the applying the CC, indices states that when you're having 2 bases that are the same, like L is here, so they're the same, and they're dividing each other. When the law of indices, you subtract their power. So this is going to give us mass times length 1 minus 2 times per time square. Alright, so when you simplify, you're going to have mass times per length times per time square. Alright, this is per length, and this is the dimension of pressure. So let's solve one more example, and after we can call it a class. Or if you are asked to find dimension of power. Alright, as we know, power is calculated using work over time. Alright, and work can be calculated using force times distance over time. Alright, now dimension of force, we have it to be mass times length times per time square, then times this distance here is talking about length, this distance here talking about length, then over time. Alright, so we are going to have, when we simplify this, we're going to have mass times length square, this length times in this length, we have length square, then times per times square, alright, minus 1, because the base is enough time and time here, so they are dividing each other, subtract the power. So when you simplify this the more, you're going to have the dimension of power to be mass times length square times per time cube, and this is the dimension of power. So guys, this is basically how you can solve problems or find the dimension of physical quantities in physics. I hope that's something interesting. And with this, we have come to the end of this class. In this video, we're going to look at the concept of vector in physics. We look at unit vectors in either 2 or 3 dimensions. Alright, so let's begin with the basic definition of vector in physics. So vector is simply a quantity that has both magnitude and direction. Alright, for instance, velocity is a vector quantity. So a body can have a magnitude of 20 meters per second in a particular direction, maybe east, west, north, or south, as the case may be. Alright, so we also have impulse. Impulse is a vector quantity. We also have acceleration, we have momentum, we have work done, we have also weight. Yes, weight is the vector quantity, and we have our field forces, that's the electrical force, the magnetic force, and gravitational force. So these are examples of field forces. They are all vector quantities in physics. Alright, so they have magnitude and direction. Now, whereas scalar quantities are those that don't have direction but they have only magnitude. Alright, so example of fundamental quantities are scalar quantity. Example, we have mass, time, we have our length, our electric current, temperature, even energy here is a scalar quantity. We also have power. Power is a scalar quantity, and the rest of them. So be sure to know how to differentiate a vector quantity from a scalar quantity. Alright, so let's write this now. Look at unit vectors in 2 or 3 dimensions. Alright, so let's look at this question. It says if vector p equals this value and vector q equals this value, find I, the magnitude of vector p and q, I, the scalar product of p and q, and I, the cosine of angle between p and q. Okay, so the magnitude of the vector should be, this is how you present it, as if you are finding the absolute value of a number or of a function. So it will be the magnitude of p equals square root of the square of the ijk value. So it's going to be the magnitude of vector p would be square root of 7 square, right, plus bracket minus 3 square, right, plus 2 square. Right, okay, so let's put everything in brackets. Right, so when you simplify this, you're going to have square root of, okay, 7 square will give us 49, alright, minus 3 square will give us 9 plus 9, alright, 2 square will give us 4. So when you simplify, we're going to have square root of 62. So when you break this down, square root of 62 will give us, let me punch it here, it's going to give us 7.87. Alright, so let's leave it in two decimal places. So this will be the magnitude of this vector P. So let's write this now. Solve for the magnitude of vector Q. Okay, so the magnitude of vector Q will be, so square root of, we have 4, put the bracket square, alright, plus 5 square, alright, plus in bracket minus 3 square. So if you simplify, you're going to have square root of 4 square is 16, plus 5 square is 25, alright, plus minus 9, minus 3 square rather is 9. Alright, so when you simplify, we're going to have square root of 50. So if we break this down, it's going to give us 7.07. Alright, so this will be the magnitude of vector Q. So it's as simple as that, guys. Now let's write this and solve for the scalar products. Okay, so the scalar product will be the sum of the product of the similar vectors. So that's the dot product of between P and Q will be, we have 7 times P4 plus minus 3 times 5. So we put it in bracket because of this negative 3, alright, plus 2 times minus 3, put it in bracket because of the negative 3. So when you simplify, we're going to have 7 times 4, we have 28, minus 3 times 5 will give us minus 15. So minus 15 times this will give us minus 15, still minus 15, alright. Then 2 times negative 3 will give us minus 6, minus 6 times this plus here still give us minus 6. So when you simplify further, you're going to get 7 as the answer. So this will be the scalar product of these vectors P and Q. Alright, so let's wipe it and solve the last question, which is the cosine of the angle between P and Q. Alright, so the cosine of the angle between vector P and Q will be cos theta equals the scalar product, that's dot product between P and Q over the magnitude of vector P and times the magnitude of vector Q. Alright, so this is Q. So remember the magnitude of vector P, when we did it, we got it to be 7.87. That of vector Q, we got it to be 7.07. Alright, so when you substitute the values, they're going to have cos theta equals the scalar product is 7 over 7.87 times 7.07. So when you simplify this, then plunge my calculator, is going to give me, so I have it to be 0.125 if you are leaving it in 3 decimal places. Alright, so we have, remember we have cos theta equals the 0.125. So to make theta the standard formula, divide both sides by cos. So this can, therefore theta will be cos inverse of 0.125. Alright, so let me punch in my calculator. Okay, so cos inverse of 0.125 will give us 82.81 if we are leaving it in 2 decimal places, and this will be the cosine of the angle between vector P and Q. So guys, this is basically the concepts behind unit vectors in 2 or 3 dimensions. This one we use, for example, is vectors in 3 dimensions. Alright, so the same approach is applied to anyone, the one that involves 2-dimensional vector and others. So with this, we have come to the end of the class. Hope you learned something interesting. In this video, we are going to look at the equations of motion in physics, how to apply them in solving questions under motion. Alright, so let's begin with the first one. So basically there are 4 of them. The first one, we have v equals u plus at. We have the second one to be x equals ut plus half at square. We have the third one to be v square equals u square plus 2as. Alright, we have our x equals v plus u over 2 in brackets t. Alright, so here our v is our final velocity, our x is our distance. Let me write it here for you. Our v is final velocity. Alright, our u is initial velocity. Then we have the t is time, the x is distance. Alright, so these equations are very important in motion under physics. So most of the problems will be solving in motion. You will need the knowledge of these equations to solve them. Correct. Alright, so very important you get used to these formulas. Now note again that motion under gravity, this equation, the acceleration here we change to acceleration due to gravity. For instance, well, let me wipe this place. If you are dealing with motion under gravity, the v will be u plus gt. Now the x will be ut plus half gt square. The v square will cause u square plus 2gx, and in that order. This fourth one does not have acceleration in it. So when you are dealing with motion under gravity, the acceleration A will change to acceleration due to gravity g. Alright. Now this equation is when the motion is with gravity, is responding to gravity. When the motion is, for instance, when a body is falling down or when an object is thrown down, so is responding to gravity. But when an object is thrown up or something is moving up, is going against gravity, the equation of motion will be u minus gt, because this minus signifies that it's going against gravity. Something is applicable to ut minus half gt square, and v square equals u square minus 2gs. Alright, so take note of this variation. This one is responding to gravity, this one is going against gravity. Right, so let's look at a couple of problems here and solve them together so that you understand how to apply these equations to any question or any problem you are dealing with. Let's wipe this. Okay, so let's solve this problem together. It says a car moves from rest with acceleration 0.2 meter per second square. Find its velocity when it has moved a distance of 50 meters. Alright, so let's begin by getting our parameters. Okay, so in this question, our initial velocity will be, since it said the car moves from rest, right? From rest means that the initial velocity will be 0. Alright, since it's at rest, nothing is happening, so the initial velocity will be 0. Okay, then our A, we have our acceleration to be 0.2 meter per second square. Alright, then we don't have our V, final velocity, and this question doesn't have time. Doesn't have time. Find its velocity when it has moved distance. Okay, you have distance to be 50 meters, doesn't have time. That means out of the three equations of motion, the one that will be suitable to solve this problem will be v square equals u square plus 2as. Alright, since we don't have time in this question, so when you substitute this value we have, you're going to have v square equals 0 square plus 2 times acceleration is 0.2 times 50. Alright, so v square equals 0 square is 0 plus, so let me multiply everything here with my calculator. Okay, so everything will give me 20. Alright, so we now have v square equals 20. So to make v the subject formula, you square both sides, so cancel the square root, so this square will cancel the square, therefore our v will be square root of 20, which will be, let me punch it, so we have it to be 4.47. We are talking about, okay, velocity meter per second. Alright, since if we leave it into decimal places, so this will be the answer to this question. Let's wipe this and look at a technical question. Okay, this question here says a ball is released from height of 20 meters. Calculate how the time it takes to fall. I, the velocity with which it hits the ground. Alright, so since the ball is released from a height, that means this is a motion under gravity. Let's bring our parameters. So in this case, we have our x distance to be 20 meter, and we are looking for time first. We don't know time, and we don't know. Okay, we have our initial velocity. It's going to be 0, so u will be 0. Let me explain. Okay, let's say this is a wall, it's a tall wall, and somebody is standing here and releases a ball. Alright, so somebody released the ball from this height. So initially, the ball will attain a initial velocity of 0, alright, before it starts making movement or falling. Hope you understand. So whereas the final velocity is unknown, so the velocity it will take from here till when it hits the ground here will be the final velocity. This one is our initial velocity, u, which is 0. So having gotten these parameters, now which equation are we going to apply? Remember, this is a motion under gravity. So we have these terms, we have time, we have u, don't have v. That means we're going to apply s equals ut plus, okay, is responding to gravity because it's falling, right? Plus half gt square. Alright, since the ball is falling, it's not going up, it's going down, is responding to gravity. Now, when you substitute this value, we're going to have our x distance is 20 equals 0 times t plus half. That means acceleration due to gravity, g is constant, which is 10 meter per second square. Alright, so when you impute it, you're going to have half times 10 times t square. So when you simplify this, you're going to have 20 equals, everything here will give you 0 plus 10 t square. Alright, so when you simplify it more, if you cross multiply, you're going to have 20 times 2, 40 equals 10 t square. So divide both sides by 10. This will cancel this. 10 t are 4. Then have t square equals 4. To make t the storage formula, you square both sides. This square can't be squared. Therefore, root of 4 is to that. Therefore, our time t equals to 2 seconds. Alright, so this will be the time. Now, let's wipe it and solve for the second way, the velocity with which it hits the ground. Okay, so we now know our t is 2 seconds. Now to get the v, final velocity, we can either use v equals to u plus gt, alright, or you can use x equals v plus u over 2 times time. Anyone will work, but let's use this one first. So to find v will be initial velocity is 0 plus our g is 10, then times our time is 2. Therefore, v will be, final velocity will be 20 meter per second. Whereas if you use this one, so to our x is 20 equals our v is unknown plus u is 0, alright, over 2. The time is 2. Alright, so when you simplify this, you are going to have 20 equals 2v. 2 times 0 is still give you 0, so it's just nothing is there, alright, over 2. You can't multiply, so you're going to have 40 equals 2v. To make v the storage formula, divide both sides by 2. Alright, therefore 40 divided to 20, therefore v equals 20 meter per second, and velocity. So anyone will work, guys. Right, so it's as simple as that. Now let's solve one more example under this before I call it a class. Okay, look at this question. It says a ball is thrown up vertically with a velocity of 40 meters per second. Calculate A, the maximum height, B, the time to reach maximum height. Alright, solution. Remember, this is a motion under gravity under gravity, right? Yeah, because look at the ball is thrown up. Now it's going against gravity because it's not falling, it's going up. Remember what I told initially when I was starting this video. Okay, now since it's going against gravity, that means our G will be negative. Alright, so let's write that our parameters. Our initial velocity is 40 meter per second. Alright, then our G will be 10 meter per second square. Alright, remember G will be negative, not be positive. Whereas our, what else do we have? We're looking for maximum height. That's, we're looking for X is unknown. Alright, then our V will be 0. Let me show you. Let me say this is a wall and this is the ground. So when you throw up an object, let's say a ball, this is a ball. Alright, you threw up a ball. Now they say that this question says that the velocity you use to throw up the ball vertically is 40 meter per second. Okay, now the final velocity V will be the velocity at this maximum height. Let's assume this is the maximum height this ball reached when you threw it up. Alright, now this will be the maximum height and this will be final velocity 0, because the ball will get to this point before it starts falling back again, before it starts responding to gravity. But this time I was going against gravity, so it's reached this point. This point is reached before it began to fall back. This is the final velocity, but before it started to fall back. Alright, so the V will be 0. So let's look at the equation of motion we're going to apply to solve this. To get this distance, the maximum height, that's the distance. So it's going to be, we use V square cos U square. It's not plus, it's going to be minus because it's going against gravity, minus 2gx. Alright, so our final velocity is 0. Initial velocity is 40 square minus 2 times, alright, 10 times x. Okay, so when you substitute this in this, when you simplify this the more, you're going to have 0 equals 40 square will give us 1600 minus 20x. So to make x, which is the distance, is the formula. This 1600 cross over this, what is going to be minus 1600 equals minus 20x. Right, so you divide both sides by minus 20. So this will cancel the dynamic. Therefore, our x will be, when this divide this, we're going to have 80. Our x will be 80 meter. Alright, so this will be the distance, the maximum height distance. Right, now to calculate the time, very simple. Let's wipe this. So remember, now our x will be 80 meter. To calculate the time, we can use v equals to u plus, v equals u minus gt. Okay, so when you substitute, you're going to have our v is 0, so equals 40, alright, minus g is 10, alright, t. Now, we make t the solid formula. This 40 equals to be minus 40 equals minus 10t. Divide both sides by minus 10, minus 10. Therefore, our t will be 4 seconds. So this will be the answer for this question. Now, this particular question can also be solved using projectile formula to solve it, because it's talking about maximum height and time to reach maximum height. So let's solve it projectile. Alright, let me show you how you can also do the projectile. Alright, in projectile, to calculate maximum height, you use u square sine square theta over 2g. So our u is 40. That's 40 square. Then this sine squared, that means you should times sine theta into 2 times. That you do sine theta times sine theta, that's multiplication to 2 times. Alright, now our theta will be 90 degrees. Let me show you, because let me show this is the wall. When you throw up a ball from up, this is the ground, and making a connection with the ground, so you have formed 90 degrees. So theta will be 90. Alright, so it will be sine 90 degree times sine 90 degrees, right, over 2 times 10. Because acceleration due to gravity, g is constant, p is 10. So when you simplify this, sine 90 is 1. This is the same thing as 40 square, which will give us 1600 over 2 times 10 give you 20. So we cancel this. 2 cancel itself, 1, 2 cancel, you're going to get 80. So you can see that you still get the same value for maximum height to be 80 meter. Alright, now the same thing is applicable to time to reach maximum height, which is, let me write this. Time to reach maximum height in projectile is calculated using u sine theta over g. Alright, so our u is 40, and 40 times sine 90 degree over 10. Alright, so sine 90 is 1, so we're going to have 40 over 10. So you still get back to 4 seconds. So either one will work for this particular question. Alright, so this is basically you can apply the equations of motion to problems involving motion and solve them. Alright, so guys, with this we have come to the end of the class. I hope we learned something interesting. In this video, we're going to look at the concept of projectile. Now let's begin with the basic definition of projectile in physics. Now, projectile in physics simply refers to an object or a body launched into space or thrown into space and moves freely by itself under the influence of gravity and air resistance. Okay, so let me illustrate the concept of projectile using this diagram. Let's say we have this diagram. Okay, let's say a missile is launched from this point. So the missile will make this parabola movement. Right? Now, this point where the missile was launched till this point it reached before it started to fall is known as the maximum height. So this is the maximum height. Alright, whereas from this point where the missile got projected till this place it fell, the horizontal distance is known as the range. Alright, whereas the time it took the missile to move from this place to this place is known as the time of light. Now, time of light in projectile is calculated using 2u sine theta over g, whereas maximum height is calculated using u square sine square theta over 2g. Range is calculated using u square sine 2 theta over g. Alright, now the time it takes the body to reach maximum height is calculated using u sine theta over g. Alright, now this movement it's made here, we call it parabola movement. This movement is not a parabola movement. in projectile, so we call it parabola movements. Alright, now so it's important you get yourself used to this formula because they will help you a lot in the calculations involving projectile, because when you miss one or when you don't know anyone, it might affect you a lot. So it's important you familiarize yourself with them, get used to it, and you'll be good to go. Alright, so let's wipe this now and look at some calculations on this. Okay, so we have this problem. It says an arrow is shot into the air with an initial velocity of 100 meters per second at an elevation of 60 degrees. Find time of light, maximum height, and range. Alright, so let's begin with time of light. Time of light equals 2u sine theta over g. And in this question, our u, initial velocity, we have it to be 100 meters per second. We have our g, acceleration due to gravity, to be, it is a constant, right, meter per second square. And we have our theta to be 60 degrees. So if you substitute the values, you're going to have 2 times 100 times sine 60 degrees over 10. So let me punch this to my calculator and get the answer. Okay, so I have it to be 17.32 if you are leaving it in 2 decimal places seconds. So this will be the time of light. Alright, so let's write this and solve for maximum height. Alright, for maximum height, the formula for it is u square sine square theta over 2g. So we have our u, g, and theta at there. So if we substitute them, we're going to have 100 square times. Now this sine square theta means you should multiply sine theta into 2 times. Alright, so you should multiply sine theta 2 times. Going to be times sine theta is 60 times sine 60. Right, so this is 0 over 2 times 10. So let me simplify this. Once you store it in my calculator, so I have it to be 375. So you're talking about height, the unit to be meter. This will be the maximum height. So let's wipe this and solve for range. Okay, so range is calculated using u square sine 2 theta over g. So when you substitute, you're going to have 100 square times sine 2 theta is 60 over g, which is 10. So when you simplify, you're going to have 100 square times sine 2 times 60 is 120 over 10. So let me point this with my calculator straight and get the answer. Okay, so I have it to be 866.02. If you're talking about horizontal distance, range is horizontal distance. We're going to be measured in the unit will be meter. Alright, so guys, this is how you can solve this particular problem here. Let's solve one more problem, and after you can call it a class. Okay, so the question says a ball thrown up vertically with a velocity of 40 meters per second. What is the time taken to reach the ground? Alright, that's time of light. Now, in this question, we have our u to be 40, initial velocity to be 40 meters per second, and we have our g, acceleration due to gravity, which is constant, 10 meters per second square. We now have our theta, and we're going to apply this formula u sine 2u sine theta over g. Now to get this theta, this is simple logic. Now look how we're going to, let me tell you the theta will be 90. Let me show you. Let's say somebody is standing beside this wall, and the person standing beside this wall throws an object according to this question. Now throws the ball vertically. Let's say the ball goes up like this. This is the ball vertically. Now as the ball is going up you, the individual that is standing beside this wall, has already made a connection with the ground. This is the ground, right? We are standing on the ground. You made a connection with the ground. Now, looking at this, you can see that you have already formed angle 90 degrees as you threw up the ball vertically. Right, so our theta will be 90 degrees. Okay, now, so the time of flight will be substitute 2u, that's 2 times 40 times sine 90 over 10. Alright, so when you simplify this, you're going to have, this is something as 2 times 40, sine 90 is 1 if you punch it into a calculator, over 10, which is 80 over 10. You can see that therefore our time of flight to reach the ground will be 8 seconds. Alright, so this is basically how you can solve problems involving projectile in physics. And with this, we have come to the end of this class. Hope you learned something interesting. In this video, we are going to look at one of the Newton's laws of motion, which is the second law. Alright, because this law is peculiar because of its relationship between impulse and momentum. Alright, so what is Newton's second law of motion? It states that, which is also known as law of conservation of momentum. Newton's law of motion, second law of motion, states that the rate of change of a momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. So mathematically, it can be expressed using F equals change in momentum. Alright, so this is Newton's second law of motion, what he's talking about mathematically. So if you cross multiply it, you're going to have Ft, which is impulse, because impulse is calculated using force times time, equals momentum, mass times change in velocity. Alright, so this is what Newton's law of motion is trying to express. Alright, so let's look at a couple of questions under this law. Use this formula to solve problems on motion. Alright, okay, so look at this question. It says a horizontal force of 15 Newton acts on a body for 4 seconds. The mass is 4 kg. Calculate the change in momentum of the body within this period. Alright, so let's bring out the parameter. We have our mass to be 4 kg. Right, we have our force to be 15 Newton. We have our time t to be 4 seconds, and we asked to calculate the change in momentum. Remember, Newton's law of second law of motion, the rate of change of momentum of a body is directly proportional to the applied force. That's force equals change in momentum. Alright, so when it cross multiply, that means impulse is equals mass times change in velocity. Alright, so from this expression we have here, we can decode or deduce that the momentum, change in momentum of this body within this time will be, since we have our force, will be 15 times our time is 4, alright, which is 60 Newton seconds. So this will be the answer to this problem. 60 Newton seconds. Is either you leave it in this unit or 60 momentum kilogram meter per second. So either of the units will work. Alright, so note that we didn't consider the values here because what is here, this equality sign here means that what is here is proportionate to what is here. Alright, so since we have the parameters for what is here, f and t, we just make use of it. 15 times 4 is 60, so 60 is equal to what is here, the change in momentum. Alright, so that will be the answer to this question. Let's solve another problem. Let's wipe this. Okay, so look at this question. It says a body of mass 6 kg moving with speed of 20 meters per second is suddenly hit by another body moving in the same direction, thereby changing the speed of the former body to 50 meters per second. What is the impulse received by the first body? Alright, let's bring out our parameters. We have our mass to be 6 kg. We have initial velocity to be 20 meters per second. We have our final velocity v to be 50 meters per second. And we don't have f is unknown, t is unknown. So we are going to apply this formula under Newton's second law of motion. F equals change in momentum about t. So when it comes multiply, have ft equals change in momentum. Alright, we have ft. This is our impulse, and this is the momentum. Alright, so from this quick expression we have here, these values we have now have f and t, and that means we're going to work. That means ft, which is the impulse, will be change in momentum. We have the mass to be 6 in brackets. Final velocity is 50 minus 20. So when you simplify this, ft, which is the impulse, will be 50 minus 20 is going to give us 30. So therefore, ft, which will be the impulse received by the first body, will be 30 times 60. It will give us 180 Newton second. So impulse is measured in Newton second. It has the same unit with momentum, Newton second. Alright, so this will be the answer to this problem. It's as simple as that, guys. So this is basically how you can solve problems involving Newton's second law of motion, the relationship between momentum and impulse. And with this, we have come to the end of the class. Hope you learned something interesting. In this video, we're going to look at circular motion and simple harmonic motion in physics. Alright, so let's begin with circular motion. Now, circular motion in physics basically is expressing the concept of centripetal force and centripetal acceleration. Alright, so let's begin with centripetal force. Now, centripetal force in physics is simply a force that keeps the body in a center of motion and is calculated using mv squared over r, whereas centripetal acceleration is the acceleration that keeps the velocity of the body in the center of motion and is calculated using v squared over r. Right, so we're going to solve problems on this, so you see how you can apply these formulas to a problem regarding it in physics. Alright, so let's go to simple harmonic motion, SHM short form. Now, simple harmonic motion in physics simply or basically is the periodic motion of a body such that its acceleration is directed toward the fixed point and is directly proportional to the displacement of distance from the same fixed point. Right, and basically there are terms used in simple harmonic motion in physics. Examples of simple harmonic motion in physics: we have the child swing, we have the rotation of the earth, we have your heartbeat. Here is an example of a simple harmonic motion. We also have car shock absorber and the rest of them. We also have the pendulum, oscillating pendulum. So anything that can make a to and fro movement can be considered as an example of a simple harmonic motion. Alright, so let's look at the terms used in simple harmonic motion. We have frequency. Alright, frequency. We have period. We have amplitude. We also have angular velocity. Alright, so we're going to look at these basic four terms in simple harmonic motion. Let's begin with frequency. Frequency in simple harmonic motion simply refers to the number of oscillation per time of a body undergoing simple harmonic motion. Frequency is calculated using W over 2 pi, where W is the angular velocity. Alright, frequency can also be seen as the inverse of period T. Alright, period, which is the time. Alright, and frequency is measured in hertz. Alright, so that's the unit of frequency in physics. Alright, now let's look at period, which is T. the time. Now, period is the number of time taken for a body undergoing simple harmonic motion to complete one oscillation, and is calculated using 2 pi over w, or you can say to be the inverse of frequency. That's period equals inverse of frequency. Note again that period can also be calculated using 2 pi square root of length over g, where length and acceleration due to gravity is given in a question. Alright, so this is pi. It can also be calculated using 2 pi square root of m over k, where m is the mass and k is the spring constant, where mass and spring constant are given in the question. Alright, so let's wipe some parts of here and look at and explain amplitude and angular velocity. Okay, before then, just note that since its period is measured in seconds, that's the units. Let's wipe this. Okay, so amplitude is the maximum displacement or distance of a body that going simple harmonic motion, and amplitude is talking about distance that is measured what in meter, whereas the angular velocity is simply the angle inclined around a circle per unit time. That means angular velocity w equals theta over time. Alright, or angular velocity can also be calculated using 2 pi f from the one of the formulas for frequency equals w over 2 pi. So when you cross multiply, w will result to 2 pi f. So that's how I got this 2 pi f. Alright, so don't be confused with it. Now note again that the relationship between angular velocity and linear velocity is expressed in this form: v equals to wr, alright, or v equals to wa at maximum. Alright, so when the distance is at maximum, right, this a is amplitude, alright, so at maximum. Now if you want to calculate the acceleration of a simple harmonic motion, is calculated using a acceleration equals minus w square r, where r is radius, or a equals minus w square a, this capital letter A, which is the amplitude at maximum. Alright, so these are basic formulas you need to get used to in simple harmonic motion, and you'll be good to go. Most of them don't need to memorize them, you can just derive them. Alright, so let's wipe this and solve some problems on it before we call it a class. Okay, so let's look at this question. It said the body of mass 20 grams moves in a circular path radius of 10 meters with a constant speed of 4 meters per second. What is the centripetal force? Alright, so before you solve this problem, note that this is very important, that in simple harmonic motion, the oscillation of a simple harmonic motion is said to be damped, D-A-M-P-E, is said to be damped when the amplitude gradually decreases with time. So take note of this. Right, so let's go ahead and solve this problem. So this is centripetal force. The formula will be mv squared over r. Alright, so our mass is 20 grams, our velocity is 4, our radius is 10 meters. Alright, so very important, you convert this gram to kilogram. So to do that, you divide the 20 by 1000. So now how to convert from gram to kilogram. So we'll be left with 2 divided by 100. We're going to have 0.02 kg. So when you substitute, you're going to have 0.02 times 4 square over 10. When you simplify this, we're going to have 0.02 times 4 square is 16 over 10. Alright, so let me punch this with my calculator and get the value. Okay, so the centripetal force will be 0.032 Newton. Alright, so that will be the answer to this question. Now let's solve another problem. Let's wipe this. Okay, so this question says, what is the period of oscillation of mass 40 kg on a spring with constant K 10 Newton per meter? Alright, so we have our parameters, mass to be 40 kg. We have our spring constant to be 10 Newton per meter. I am looking for T. Period is unknown. That means we are going to apply 2 pi square root of m over k. Alright, since we have mass and spring constant, so we're going to have 2 pi square root of mass is 40 is in kg, so no need converting over the spin constant 10. So when you simplify this, then you have 2 pi square root of 4. Square root of 4 give us 2. So then you have 2 pi times 2. So the answer to this question, if you are leaving it in pi, will be 4 pi seconds. Right, so that would be the answer to this problem. So let's wipe it and solve one more example under simple harmonic motion. Okay, so let's look at this problem. It says if the frequency of 0.75 meter long simple pendulum is 1.5 Hz, the angular frequency on the corresponding reference circle in radii per second is what? Now note that angular frequency or angular velocity is measured in this unit radii per second. Take note of this. Alright, so let's bring the parameters. We have our frequency to be 1.5 Hz. We have our radius length to be 0.75 meter. Then we are looking for angular frequency. So we still apply the formula for angular velocity to this. Alright, or okay, let me just say, let's use the frequency formula. Frequency equals W over 2 pi. Alright, so this W here also representing angular frequency will be, when you cross multiply, the angular frequency will be 2f pi. So when you substitute, angular frequency will be 2 times the frequency here is 1.5 pi. So to give us, when you simplify it, you're going to have 3 pi radii per second. Alright, so this will be the angular frequency. So guys, this is basically you can solve problems involving circular motion and simple harmonic motion in physics. And I hope I explained everything easily for you guys. And with this one comes the end of the class. So that's something interesting. In this video, we're going to look at the concept of collision in physics. Alright, so collision is something we see in everyday life. Alright, so when two bodies hit together, collision automatically occurred. Alright, so that's collision whenever two bodies hit together. Okay, so basically there are two types of collision in physics. We have the perfectly elastic collision and perfectly inelastic collision. Alright, now perfectly elastic collision is a type of collision with both kinetic energy and momentum are conserved, and it can be calculated using m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. Whereas perfectly inelastic collision is a type of collision in which only momentum is conserved. Kinetic energy is not conserved in perfectly inelastic collision. Right? And for perfectly inelastic collision, it can be calculated using in physics using this formula m1 u1 plus m2 u2 equals v in bracket m1 plus m2. Right, so this is the formula used to calculate perfectly inelastic collision. This one is for perfectly elastic collision. Alright, so let's look at some problems on collision calculations in it and apply this formula to them to get whatever we're asked to find. Alright, note that most of your physics questions or most questions for collision usually come from perfectly inelastic collision. Alright, so take note of that. Now let's get some problems and solve. Let's write this. Okay, let's look at this question. It says a block of mass 0.01 kg moves horizontally with a speed of 400 meters per second and embeds itself in a block of mass 0.39 kg that is initially at rest on a frictionless table. Find the final velocity of the bullet and block. So let's get our parameters so that we know the right formula to apply for this problem. Okay, in this question we have our m1 to be 0.01 kg. Alright, so we have our u1 to be 400 meters per second. We have our m2 to be 0.39 kg. We have our u2 to be when m2 is 0.39 kg, the velocity is at rest. Alright, initially at rest, that means will be 0. Okay, so we are looking for v. Now v. That means we're going to use this question is under perfectly inelastic collision. So we're going to apply m1u1 plus m2u2 equals v in bracket m1 plus m2. So we are looking for the velocity of impact, right? The final velocity v. So when you substitute these values, you're going to have, remember this u is your initial velocity. We have two initial velocities for this question and two masses. Alright, no, now let's impute the value. We're going to have our m1 is, we're going to have 0.01 times u1 is 400, right? Plus m2 is 0.39 times 0, right? Equals v in brackets. We have 0.01, right? Plus 0.39. So when you simplify this, you're going to have, so let me punch this in my calculator. 0.01 times 400 give us 4. Alright, everything here, 0.39 times 0 still give you 0. So we left 4 at the left side of the equation equals v in bracket. So let me punch what is in that bracket. Okay, so when you add what is inside the bracket, you're going to have 0.4. So to make v the solid formula, divide both sides by 0.4. This to cancel this. Therefore, our v will be 4 divided by 0.4. It will give us 10. So we're going to have the final velocity to be 10 meters per second. So that will be the final velocity. Now let's wipe this and solve another problem. Okay, let's look at this question. It says a revolver of mass 6 kg releases a bullet of mass 0.05 kg at a speed of 200 meters per second. What is the revolver's speed of recoil? Alright, so let's get the parameters. Our u1 will be 0, our m1 will be 6 kg, our u2 will be 200 meters per second, our m2 will be 0.05 kg. Right, why our u1 is 0? Because when the revolver is released from the bullet is released from the revolver, rather, the bullet initially we have a velocity of 0 before it starts moving at this velocity of 200 meters per second. Alright, so don't be confused with it. So initial velocity will be 0. Okay, so and we are looking for, we ask what is the revolver speed of recoil. Alright, so we're looking for final velocity, which is unknown. That's the velocity is used to return recoil. Alright, so now we're going to apply, this is perfectly inelastic collision. We're going to apply m1u1 plus m2u2 equals v in bracket m1 plus m2. So when you substitute, we're going to have our m1 is 690 plus, so m2 is 0.05 times u2 is 200, right, equals v in brackets. So we have 6 plus, right, 0.05 all in brackets. Okay, so when you simplify it, everything I give is 0. So let me multiply 0.05 by 200. Okay, so we're going to have 10 equals v in bracket. So 6 plus 0.05 give us 6.05. So to make v the solid formula, divide both sides by 6.05. 6.05. If we cancel this, so therefore 10 divided by 6.05. Let me punch it. Alright, so our final velocity will be 1.65. If you are leaving it in 2 decimal places, meter per second. Right, so this will be the speed of recoil, the final velocity. So let's wipe and solve one more example, and after you can call it a class. Okay, so let's look at this typical question. It says a rifle fires a bullet of mass 0.01 kg with a velocity of 200 meters per second. Find the recoil velocity if the mass of the rifle is 6 kg. Right, let's get our parameters. In this question, we have our m1 to be 0.01 kg. We have our u1 to be 300 meters per second, and we have our m2 to be 6 kg. Our u2 will be 0, right, because the waveform is not moving. All right, so we are asked to find the recoil velocity v. For example, we still apply, this question is under perfectly inelastic collision. Like I told you, most of the questions we see in collision will come from perfectly inelastic collision. All right, so we're going to final velocity is unknown, so we're going to apply m1 u1 plus m2 u2 equals v in bracket m1 plus m2. So let's substitute the value. We're going to have m1 is 0.01, right, times 300 plus our m2 is 6 times 0 equals v in brackets 6 plus 0.01. So when you simplify this, 0.0 times 200 will give us, we're going to have 3. So 6 times 0 is 0. Everything is, we only have 3 at the left side of the equation, because so when you simplify this, v in brackets 6 plus 0.01 give us 6.01. Alright, so to make v the solid formula, divide both sides by 6.01. This will cancel this. Therefore, our final velocity v will be, let me point this with my calculator. 3 divided 6.01. Okay, so I have it to be 0.49, which is approximately, if we are leaving it to one decimal place, 0.5 meter per second. Alright, this is one. Okay, so this is basically how you can solve problems involving collision in physics. We looked at perfectly elastic collision, perfectly inelastic collision. Alright, so this is easy, guys. With this, we have come to the end of the class. Hope you learned something interesting. In this video, we are going to look at the concept of work, energy, and power in physics. Alright, so let's begin with work. Now, basically in physics, work is defined as the product of force to the distance of a body. That means work equals force times distance. Work can also be calculated using mgh when mass and height are given as parameters and force is not given. Alright. Also note that when force is inclined at an angle theta to the horizontal, then the work done, W, will be calculated using force times distance times cos theta, where theta is the angle. When the force is inclined to an angle horizontally, whereas when the force is inclined to an angle vertically, the work will be calculated using force times distance times sine theta. So take note of this difference. This one is when it's inclined, force is inclined to an angle horizontally, whereas this one is when force is inclined to an angle vertically. Alright, so let's solve a typical problem on this before we go to energy. Let's wipe this. Okay, so let's look at this question. It says a ball is pulled 20 meters along a horizontal plane with a constant force of 10 Newton applied parallel to the plane in the direction of angle 60 degrees to the horizontal. Calculate the work done. Alright, so we have our parameters. We have our force to be 10 Newton. We have our distance to be 20 meters. We have our theta to be 60 degrees. Alright, so to calculate the work done will be force times distance times cos 60 or cos theta. When you substitute, then you have work equals, so the force is 10 times 20 times cos 60. Note that we use cos because of the angle is inclined to the horizontal. I think if the angle was inclined to the vertical, we would have used sine, but since it's not vertical, it's horizontal, we make use of cos. Alright, so don't make the mistake of using cos when it's horizontal in place of sine when it's vertical, right? So don't make that unnecessary mistake. So let me point this my calculator. Work will be equals, so I have it to be 100, and work is measured in joule, so to be 100 joules. Alright, so let's wipe this and solve one more problem of work before we go to energy. Okay, so this question says an object of mass 100 kg is released from rest and falls through a distance of 10 meters. What is the work done by the gravity? Alright, so our parameters, we have our mass to be 100 kg. We have our distance, it could be used as, since I'm talking about height, let's use height here to replace distance 10 meter, and we are asked to find work done. Alright, so we're going to use work done will be mgh, mass and acceleration due to gravity. So acceleration due to gravity here is 10 meter per second square. So since the object raised from rest is falling, right? So it fell and falls through a distance of 10 meters. That means it was responding to gravity. It should not be minus 10 meter per second square. And if it was going up, the object was thrown up, it would have been against gravity. This would have been a negative number. Alright, so take note of that. So we're going to have, when you substitute, we're going to have work done will be 100 times acceleration due to gravity, 10 times, then we have the distance, which is the height here, times 10. So when we multiply through, we're going to have the value to be 10,000 joules. And that will be the answer to this question. Okay, so let's wipe this and look at energy. Alright, so what is energy? Energy is simply the ability or capacity to do work. Alright, so energy equals work done. Alright, and work done is calculated using force times distance, right? Now, the difference between work and energy is that energy is a scalar quantity, whereas work is a vector quantity. Now, we have two major types of energy. We have kinetic energy and potential energy. Alright, so kinetic energy is the energy possessed by a body in motion and is calculated using half mv square, whereas potential energy is energy possessed by a body at rest. Alright, and is calculated using mgh. Now, the relationship between kinetic energy and potential energy, half mv square equals to mgh. So this will cancel this. Alright, so we'll be left with v square over 2 equals gh cross multiply. So we have 2gh equals v square. Make v the solid formula. So this will cancel this. Therefore, v velocity will be square root of 2gh. And this is the relationship between kinetic energy and potential energy. So take note of this expression, are very important in this concept of energy. Right, so let's wipe this and solve some problems. Okay, this problem says that means the kinetic energy of a gear of mass 40 kg only with a velocity of 3 meters per second. So our m is 40 kg, our velocity is 3 meters per second. Alright, then for kinetic energy, the formula is half mv square. So when you substitute, when you input the values, you're going to have half mass is 40, this times 40 times 3 square. So when you simplify, you're going to have half times 40 times 3 square is 9. Alright, so when you simplify this the more, you're going to have 360 divided by 2. So this is cancelled, you're going to have 180 joules. So energy, the unit of energy is joules, is measured in joules. Alright, so let's wipe this and solve another problem. Okay, so let's look at this question. It says a ball of mass 0.4 kg is dropped from a height 20 meters. Calculate its velocity at the ground. Alright, so let's bring out our parameters. We have our mass to be 0.4 kg. Okay, we have our height to be 20 meters. We are looking for velocity. That means we are going to use the formula for the relationship between potential energy and kinetic energy, which is v equals to square root of 2gh. Alright, so let me show you how we derive it again. Potential energy is mgh and kinetic energy is half mv square. So m will cancel this m, so we cross multiply 2gh equals v square. To make v the solid formula, you square both sides, this will cancel this. Therefore, V will give you this. Alright, so now let's input the values to be V equals square root of 2 times our acceleration due to gravity will be 10 meters per second square, so times 10 times our height is 20. That means we're not going to make use of this mass. Alright, so it's not relevant to this question since this is the formula we are working with. Alright, so let's simplify for the V will be square root of 20 times 10 give us 200. 200 times 2 give us 400. So square root of 400 give us 20. Therefore, our velocity will be 20 meters per second. And that will be the answer to this question. Alright, so let's wipe this and go to power. Okay, so note that power is a scalar quantity. Let me say it now before we go to power. Power is a scalar quantity, it's not a vector quantity. Alright, so let's wipe this now and go to power. Okay, so power is basically the rate of used up energy. So energy we used up is power with respect to time. Alright, so it's the rate of using up energy. That means power can be calculated using work over time. Alright, so another way you can represent this, it can also be calculated using mgh over time. It can also be calculated using, depending on the parameters you have, force times distance over time. And it can also be calculated using force times velocity. Alright, because this work is force times distance to give the work. That's why I have force times distance here over time. Work can also be calculated using mgh. Alright, so you can also calculate work using mgh. That's why I have mgh here. And this force times velocity, remember this distance over time or displacement over time, depending on the parameter, will give you velocity. So that's why I have velocity here. Alright, so let's look at our power is measured in watts. So let's look at some examples and solve together. Okay, a rocket, let's look at this question. A rocket of mass 40,000 kg propelled by a force of 1,000 newton acquires the speed of 3,000 meters per second. Determine the power expended, that's the power used. Alright, so let's bring out the parameters. We have our mass to be 40,000 kg. We have our velocity to be 3,000 meters per second, and we have our force to be 1,000 newton. Alright, so to determine the power, remember power is work over time. Alright, and since we don't have distance given in this question, because if we break this down, this formula down, it will be force times distance over time. Alright, or mgh over time. Since we don't have distance or height in this expression, and we don't also have time in this expression, yes, we don't have time. That means when you break this down, it can also give us force times velocity. That means this is the one we're going to work with. So power in this case will be force times velocity, which will be, the force here is 1,000 times 3,000. Alright, so when you divide this, you're going to have the power to be 1,000 times 3,000. You're going to have 3 million. So we're going to have 3 million watts. So this will be the answer to this question. So let's write this and solve one more problem on this before I call it a class. Okay, this question says calculate the power of a pump release 500 kg of water through a vertical height of 4 meters in 5 seconds. Assuming okay, G is 10 meters per second square. So the parameters here, we have the mass to be 500 kg. We have the time to be 5 seconds. Right, so we have the height to be 4 meters, and we are looking for power. Is unknown, so power will be mgh over time. So when you substitute the value, we're going to have the mass is 500 times the acceleration due to gravity given here is 10, alright, times height is 4 over the time is 5. So when you break this down, you're going to have 500 times 10 is going to give us 5,000. 5,000 times 4 will give us 20,000 over 5. So when you simplify this, you're going to have the answer to be 20,000 divided by 5 will give us 4,000 watts. Alright, so this will be the answer. So this is basically the concept behind work, energy, and power in physics. And with this, we have come to the end of the class. So let's start interesting. In this video, we are going to learn how to solve vectors with Casio calculator easily in a matter of seconds. Now, after going through this video, you will be able to solve vectors with Casio FS 991 ES loss calculator easily in a matter of seconds, especially for multiple choice questions. So stay with me till the end of this video. Okay, let's begin. Let's look at the examples I have here and solve them together. Example 1 here says, if A and B are vectors specified by A equals these values and B equals these values, find A plus 3B. And these are our options. So right now, let's bring the Casio calculator we will use to solve the problem together. Okay, to begin with, we will have to put our calculator in vector mode, and to do that we press the mode button. So vector is category 8, so we press 8. So the calculator is now in vector mode. So what we are going to do next now will be to store these values 2, -3 and 5 as vector A. So vector A there is option 1, so we press 1. So the dimension of the vector is 3-dimensional vector. So we go for option 1. So we have 2, -3 and 5. Note that as you are entering the values, they are being stored in the calculator automatically. So what we will do now will be to wipe out these values, knowing that they are already stored in the calculator. So we wipe out these values to impute the values for vector B. So the next thing we do will be to press Shift button 5. When you look at button 5 closely on your calculator, you will see vector written on top of it. So you press button 5. So this time around we go for data, which is option 2, and go for vector B and input the value for vector B. So the values for vector B here is in 3 dimensions. So we go for option 1. So the values here are 5, 3, and -4. So right now we are going to find the addition of the vectors. So we are going to wipe out these values, knowing that they are already stored in the calculator. So to begin with, what we will do will be Shift button 5. So let's check the question. So we have to find A plus 3B. So it will be vector A, which is this plus 3B. So vector B, Shift button 5. That's option 4 is vector B. Very, very simple. So right now let's press equal to and get our answer. So this is our answer, 17, 6 and -7. So the answer to this question is option A. Very, very simple. So that's how you can solve vectors basically with the Casio calculator, particularly for addition, subtraction, and the rest of them. So let's solve example 2 now. Let's solve example 2. We are going to clear the calculator since we are going to store new values in the calculator. To do that, we press Shift button 9 and follow the instruction. We want to clear all, press 3, press equal to, press equal to again. So let's solve example 2. It says compute 2a plus b minus c, given that vector a equals this value, vector b equals this value, and lastly vector c equals this value. So let's go back to vector mode in the calculator. Vector mode is option 8. So let's begin with vector a. Let's store the values for vector a. So it's in 3 dimension, option 1. So we have 4, 0, and minus 1. Very, very simple. Let's wipe out these values now and store the values for vector b, having known that these values are stored in the calculator. So we press Shift button 5, data. So vector b2 is in 3 dimensions, so we go for option 1. So we have minus 1, 3, and 2. So let's wipe out these values, knowing that they are already stored in the calculator, and store the values for vector c. So press Shift button 5, data. So vector c is 3, is in 3 dimensions. So let's check the values for vector c. 0, 5, minus 1. So we have 0, 5, and minus 1. So we have stored the values. So right now we go ahead and find 2a plus b minus c. We're going to wipe out these values, knowing that they are already stored in the calculator. So we press Shift button 5. So we have vector a, which is 3. So we have 2a. You come here and put 2. Vector a plus b, that vector b. Press Shift button 5. So we have minus c, vector c. Shift button 5, vector c is 5. So that's it. Let's press equal to now and get our answer. Very, very simple. So our answer is 7 minus 2 and 1. 7 minus 2. So the answer to this question is option C. Very, very simple. So that's how you can solve a question like this with a calculator. Let's now solve example 3. So let's clear the calculator rather. Shift button 9 and follow the instruction. So the question says find the absolute value of the vector. Okay, remember you are asked to find the absolute value. Note that you are asked to find the magnitude of the vector. So to do that now, let's impute the values. So we go back to vector mode, we press mode, category 8. So let's store this value as vector a. So we have in 2 dimensions, we have minus 3, 2, and 5. So let's wipe out these values now and then find the absolute value of vector A. So we do shift. This time around, we're not going to press button 5. We press this hip button HYP. When you look at it on top, you see absolute on top. So you press shift the button. So vector A, press shift button 5, vector A, press 3, and close the brackets. Very, very simple. So let's press equal to now and get our answer. 6.16. So let's check if option D is the answer. Let's find square root of 38. So we need to clear the calculator, shift button 9, this. So square root of 38, we change it to decimal value, press SD. So 6.16, that's what we got. So option D is the answer to this question. Very, very simple. So let's now solve the fourth example we have there. Very, very simple. It's given that A equals and B equals, find A dot B. Very, very simple. So let's go back to vector mode now. Category 8. So let's store these values for vector A, which is this one, is in 3 dimensions. So we have 3, 4, and 5. So let's wipe out this value, knowing that they are already stored in the calculator, and input the values for vector B. So we press shift button 5, data 2, vector B is 2, is in 3 dimensions, press 1. So we have 6, 8, and 10. Very, very simple. So right now, let's wipe out these values, knowing that they are already stored in the calculator, and find A dot B. So we press shift button 5, vector A, which is 3, shift button 5. So look at the dot option 7. So press 7. Then vector A dot vector B, press shift button 5. So vector B is option 4. That's vector A dot vector B. Very, very easy. So let's now press equal to and get our answer. $100. So the answer to this question is 100. Very, very simple. So right now we're going to go back to the next slide and solve the questions there, and after it we'll call it a class. Very, very simple. Okay, example 5 here says find the magnitude of this vector. So right now we have to clear the calculator and store these values as vector A. So we press shift button 9 and follow the instructions, press 3, equal to. So we go back to vector mode, press mode, category 8. So let's store these values as vector A. Is in 3 dimensions. So we have there 3, 4, and 5. So let's wipe out these values, knowing that they are already stored in the calculator. So the next thing we do now is to find the magnitude. Like I told you earlier, that magnitude is same thing as absolute value. So you press shift this button, HYP. That's the button you press. When you look at it closely, you see absolute on top. So you press the button So the absolute value of vector A, that's the magnitude. So we press shift button 5, vector A, which is 3, and close the bracket. So let's press equal to now and get our answer. 7.07. So the answer to this question is option A. Very, very simple. So let's solve the last example in this slide, and after it we call it a class. So the question says find the angle between A equals this value and B equals this value. So what we're going to do now will be to store these values as vector A and these values as vector B. So let's begin. We're going to clear the calculator because we're going to store new values. So we press shift button 9, 3, 40, 40. Let's go back to vector mode, category 8. So vector A, press option 1. Enter dimension, press 1. So input the values. We have 3, 2, and -6. Very, very simple. So let's wipe out these values knowing that they are already stored in the calculator. Okay, let's store these values as vector B. So we press shift button 5, data, which is 2, vector B is 2. So it's in 3 dimension, you press 1, option 1. So input the values, you have 4 minus 3 and 1. That kid here, there is one invisible one beside it. So let's wipe out these values knowing that they are already stored in the calculator. Okay, so right now let's find the angle. Though I've already shown some solutions to it. So look at the formula I used to find the angle. Cos theta equals A dot B over magnitude of A times magnitude of B. So let's find A dot B and check if it will actually give us 0 as an answer. So to do that, we press shift button 5. So we press vector A, which is option 3, dot shift button 5, dot is option 7, vector B, shift button 5. So vector B is option 4. Very, very simple. Let's now press equals 0. So it gave us 0. So this value is correct. So let's also check for magnitude of A times magnitude of B. So you wipe out this. So what we're going to do now will be shift this hit button, vector A, shift button 5, vector A is 3 times shift button 5, vector B is 4, and close the bracket. So let's press equals and see what we will get as an answer. 35.69. So when you approximate this 9, it will give you 35.7. So that's what I have here is correct. So once you get this point here, almost done, you make theta the subject of the formula. When you make theta the subject of the formula, this is what you will get. So your answer now will be theta equals cos inverse of 0 over 35.7. So let's check it with the calculator. We wipe out this. from vector mode. So you will clear the calculator, press shift button 9, follow the instruction. So let's find cos inverse of 0 at 35.7. Shift cos, and function 0 over 35.7. So close the bracket. Very simple. So let's press the button and see what we're going to get as an answer. 90. So the answer to this question is 90. Very simple. So we have come to the end of this video. Once you are done, you press shift button 9, 3, and equal to clear the calculator to remove it from vector mode.